Trig word problems. Lesson 9-3 homework, aka applications. Let's go ahead and take a look at number 1. Lenora wants to build the bike ramp shown and is trying to determine how much wood she needs. How long is the base of the ramp and how long is the ramp itself? Okay, so we have two objectives. We need to first figure out how long is the base of the ramp. And 2, we got to figure out how long is the ramp itself. So if I zoom in closely, notice that we have a right triangle. I'm going to go ahead and redraw that triangle. So it's a right triangle. There's this 20 degrees, so it means we're dealing with an angle here. So this is 20 degrees. And this is 10 feet tall, so that has to be 10 feet tall as well. Okay, so one thing that I need to figure out is how long is the base of the ramp, which we're going to call the base. This is the base of the ramp. We're going to let that be x. So the base of the ramp is x. So I'm going to call this x. Note that the 20 degrees here, that's my angle of reference. That's my starting point. So I'm going to use that to label the figure. This is going to be opposite. This is going to be adjacent. And then this is the hypotenuse because it's across from the 90-degree angle. Now, what I'm going to do is I'm going to highlight the given values. I have 10 feet here, and this is one of my objectives to figure how long the base of the ramp is. So if I have adjacent and opposite as my given values, let's write SOHCAHTOA so I can figure out which one or which trig function do I use. Do I use SO, CA, or TOA? Because we have opposite and adjacent, that means we're going to be using the tangent function. So I write tangent of 20, so 20 is my angle of reference, which I'm going to include, which is equal to opposite over adjacent. That's 10 over x. And since x is in the denominator, that means I can swap it with tangent of 20. Meaning I can just do this. X equals 10 over tangent of 20. So I'm going to use my calculator now. I'm going to clear the memory and I'm going to press mode on my calculator. And I'm going to arrow down. And then see, this is where the calculator is in radian right now. We don't want that. We actually want that in degree. So make sure you set your calculator to degree. Press enter. So you're officially in degree. How to quit the calculator, you press second mode, and then you're now on the regular screen. To figure out what x is equal to, you're going to do 10 divided by tangent of 20. Press enter, and you have what x equals. X is approximately 27.5 feet. So what does this mean? That means that the base here is approximately 27.5 feet long. Now, that's one of the things that we have to do, right? The other thing that I have to do is I have to figure out how long is the ramp itself. So this is the ramp, right? So if this is the ramp, this is looking at it in 3D. Now looking at it in 2D, this is the ramp, aka our hypotenuse. So I'm going to call the ramp y. So here's y. So what do I need to work with? I would use the original 10 feet that we had in the problem, and I'm going to figure out what y is equal to. So now ignore this, work with this opposite side and this hypotenuse, which means we're going to be using or the sine function. So I write sine of 20, which is equal to opposites over hypotenuse. That's 10 over y. Notice that y is in the denominator, so I'm going to go ahead and swap places with the sine of 20. I have y equals 10 over sine of 20. That means I'm going to use my calculator. I press 10 divided by sine of 20. Make sure your calculator is in degree. So y is equal to, or y is approximately 29.2 feet. So I figure out what x and y are. Okay, let's take a look at number 3. It says, due to a storm, a pilot flying at an altitude of 528 feet has to land. If he has a horizontal distance of 2,000 feet to land, at what angle of depression should he land? Draw a picture, label it, and solve the problem. Okay, so we're seeing that a pilot is flying at an altitude of 525 feet. So I'm going to draw my figure. We're going to say that this is 528 feet, right? And the pilot is right here. So again, a pilot is flying at an altitude of 528 feet. Okay? Now, he has a horizontal distance of 2,000 feet to land. So this is the horizontal distance, and we're going to call that 2,000 feet. Okay? Now, we're talking about the angle of depression here, right? So this is my pilot, and this is the horizontal line of sight. Now, if the pilot looks down, it's going to look something like this, right? Which you have here in the red dashed lines, the angle of depression. And notice that the question says, what angle of depression should he land? We don't know what the angle of depression is. So we're going to call this x. So I'm going to call that x, right? So x degrees. So because this is x degrees, right? This creates an alternate interior angles, meaning that if this is x degrees, this has to be x degrees as well. Okay? So x degrees. So here we go. This is my angle of reference here. I'm going to label my figure. I'm going to call this the opposite side. This is my adjacent side. And then, yes, this is a hypotenuse because, look, if we're talking about the altitude and the horizontal line here, or the land here, they are actually perpendicular to each other at a right angle. Okay? So I'm going to highlight the given values, 528 feet and 2,000 feet. I love how both of them are in feet, so I don't have to do any conversions whatsoever. So let's go ahead and write SOHCAHTOA. SOHCAHTOA. I have opposites and adjacent. That means I'm going to use the tangent function. So I write tangent of my angle of reference, which is x, equals 528 feet over 2,000 feet. And because I'm looking for that angle, I have to use the inverse trig function. So I write tan minus 1 of 528 over 2,000, which is equal to x. Okay? So let's go ahead and put that in our calculator. So it is second tan, so you have tan inverse, 528 divided by 2,000. Press enter. So that is approximately 14 point, if I went around to the nearest tenth, it's 14.8 feet. So that's approximately X at an angle of depression. So this here is 14.8 feet. Or no, not feet. What am I doing? I'm not using feet. I'm using degrees here. So it's 14.8 degrees. Okay. So here, at what angle of depression should the pilot land? That would be at 14.8 degrees at an. Hugo is standing in the top of the Gateway Arc looking down on the Mississippi River. The angle of depression to the closer bank is 45 degrees, and the angle of depression to the farther bank is 18 degrees. The arc is 630 feet tall. Estimate the width of the river at that point. Okay, so we have this word problem, and we have this picture. It looks like we're dealing with a lot of information, right? This doesn't look too promising, but I'm going to try to break this down and hopefully it makes sense. So we have the person here. So there's the arc, and the person is standing right here. And if this is my horizontal line of sight, and they were to look down closer to the bank of the river, so this is the river here. If they look close, so this is the horizontal line of sight, and they look close to the river, this is the angle of depression at 45 degrees, okay? So this is 45 degrees, just like you see over here. So if this is 45, that's 45, if that makes sense. And then there's another angle of depression. So here's the horizontal line of sight, and if the person is looking, farther, as so right here, this is 18 degrees. My goal here, because we know that this, this arc is 630 feet tall, we're gonna have to estimate the width of the river from this point. Okay. So notice that we have this here and this here. If I can figure out how long this thing here is, and if I know how long this thing here is, I'm going to subtract, or I'm going to find the difference, so I can actually figure out how long the river is, or the width of the river, okay? So, let me go ahead and try to make some more sense. First of all, you have to recall the alternate interior angles. That's going to be our friend for this game here. Again, here's the person, or really the person's like right here, and then there's this horizontal line of sight, right? And they look down here. So basically I have this angle. Now, if I were to do this, if this here is 45 degrees, right? If this here is 45 degrees, then this here is also 45 degrees using the alternate interior angles theorem. So I can go ahead and put 45 degrees right there. Okay, again, one more time. Here's the horizontal line of sight. They look down at a 45 degree angle. So if this is 45 degrees, this is 45 degrees. So let me go ahead and draw that triangle, specifically this triangle. So here's 630 feet, and then this is 45 degrees. I want to figure out how long this base here is. We're going to call that X. And because this is a 45, 90, this is also 45 because of, 45, 45. It's a special right triangle. Okay? So across from 45 degrees, this is A. Across from 45 degrees here, that is also A. But look at that. If A is 630, X is equal to 630. So we know what the base of this thing here is. That's wonderful, okay? So I'm done with that part. But I need to figure out what this part here is. All right? So let's take a look. So here is this triangle. Note that since the person is standing here, right, and looks, or basically looking across, and then looks at the farther bank of the river at an angle of depression at 18 degrees, right? So this is 18 degrees. So if I were to do this, if I create this little line here, if this here is 18 degrees, right, then this here has to be 18 degrees as well. So I'm going to put 18 degrees there. So what do I have? I have this triangle, which I'm going to redraw. So how tall is the arc? It's 630 feet. And then, again, if this is 18 degrees, this is 18 degrees. That's using the alternate interior angles theorem here. So now I got to figure out how long is this base. We're going to call that X. We're not going to include the 630 at all. We're just going to call this X. We're going to subtract anyways at the end. So just call this X. Make our lives a little easier here. So label. This is my angle of reference, right? So I'm going to call this opposite. I'm going to call this adjacent. And yes, this is a 90-degree angle because this is perpendicular to that. And then this is the hypotenuse. So I have opposite, adjacent. That's using the tangent function. So tangent of 18 equals 630 over x. So we have x equals 630 over tangent of 18. Using my calculator, I have 630 divided by tangent of 18, which is approximately 1938.9, okay? So what I'm trying to say here is this base here, the bigger base, is approximately 1,938.9 feet. So if this whole thing is this, and this part here is 630, then what is left, right? What is left? So I do 1938.9 minus 630, and that's going to give me 1,308.9 feet. So this here is 1,308.9 feet long. Okay? And that's your answer. I know that was a lot. You have to know your theorems and you have to figure out how to work with this type of word problem when there's just so much given, right? You have to break it down. And that's what I try to do. Okay. Now, these things here are review. You're going to use for 6 to 8. So for 6 to 8, you're going to use special rights. So review your special rights. And then for 9 to 11, you're going to use trig. Okay? And for 9 to 11, my hint to you all is to figure out what the angle measures are, right? That means you're going to have to use the inverse trig functions for these, okay? We've already done examples like this in the past, so again, this is review. I'm not going to go over these problems. This will be an exercise for you to do, okay? So again, 6 to 8, special rights, use special rights. And then 9 to 11, you're going to use trig, particularly the inverse trig functions. All right, that'll be all. Bye-bye.